Hello everyone. In this video, we will discuss about the heat and the kinetic theory of gas and different assumptions of kinetic theory we will discuss here. First, we will discuss the basics of heat. Heat is a physical cause of the sensation of hotness and coldness. It can be defined as an effect in a system which occurs solely as a result of temperature difference between one system and another system. We all know that unit of heat in SI system is joule. Again, heat is a transitory quantity and is never contained in a body. Hence, it is not a property of a system. Heat flowing into a system is assumed to be positive and heat flowing out of a system is assumed to be negative. When a hot and a cold body are brought into thermal contact, there will be a transfer of heat from the hot body to the cold body and a state is reached where temperature of the bodies are said to be equal. The state is called thermal equilibrium. Thus, the concept of temperature applies to equilibrium states only. Now we'll discuss the basics of kinetic theory of gas. The motion of the molecules of matter is the fundamental fact on which kinetic model has been built. Kinetic theory explains the three states of matter, but for liquids and solid, it is still in the stage of dawn. Even though kinetic theory is applicable to all matter, it has been applied more extensively to gases. According to kinetic theory, a perfect gas is composed of a large number of molecules where all molecules are identical and have the same mass and size. At low pressures, the volume occupied by the molecules is negligible when compared with the volume of the container. The molecules occupy 1/1000 of the total volume of the gas. Therefore, at low pressures, the molecules are far apart compared to their diameters, so that the attractive forces between them are negligible. Again, the molecules which are point masses or small elastic spheres are in a state of chaotic straight line motion during which they collide with each other and with the side of the container. Kinetic theory postulates that the molecules exert no force on each other, that is, no attractive or repulsive forces, except when two of them happen to come so close together that they act strongly upon each other, and a collision which is assumed to be perfectly elastic occurs, and each collision changes both the magnitude and the direction of movement of the two colliding molecules. The relative velocities of molecules change from small values at the instant of collision to very large values. An ideal or perfect gas has been defined as that fluid which obeys a characteristic gas equation and whose specific heat remains constant. So we will say the assumptions from the above discussion that the molecules are perfectly elastic and perfectly rigid, which implies that no time or momentum is lost during collisions with the boundaries, and there cannot be any frictional effects between colliding molecules. The length of path between collisions with the enclosure is not changed by the presence of molecules themselves. The volume occupied by the molecules is negligible compared with the total volume. The attractive forces, including the effect of gravity between adjacent molecules, are negligible, and hence the molecules can be assumed to travel in straight lines. So, from these assumptions, one can readily obtain the characteristics equation PV is equal to RT. Thank you for listening.